Hello everyone. Today we are going to make a 5 kilowatt wind turbine using MATLAB. This is the equation for output power of turbine, wind turbine. PM output power will be 1 upon 2 into Cp lambda beta into rho into A into V cube. Okay. So this value PM is mechanical power output. In watt, rho is the air density. The value will be 1.225 kilogram per meter square. Then Cp will be performance coefficient of wind turbine. A is the area swift meter square. V will be wind speed meter per second. Lambda will be tip speed ratio. Beta will be blade pitch angle in degree. Okay, the Cp equation will be C1 into C2 upon lambda I minus C3 into beta minus C4 into beta power x minus C5 into e to the power minus C6 upon lambda I. Okay, C1, S2, C6 are constants. Okay, now 1 upon lambda it will be 1 upon lambda plus 0.08 beta minus 0.035 upon 1 plus beta cube. The lambda would be omega r into r upon v. Omega r will be the 50.775 while after calculating the value. The Cp will be 0.41034 will be there. For 5 kilowatt, lambda is equal to 8.1. Cp lambda comma beta will be 0.41034. V will be 12 meter per second. Beta is equal to 0. R will be 1.91431. C1 will be 0.5, C2 will be 116, C3 will be 0.4, C4 will be 0, C5 will be 5, C6 will be 21. This data where I have taken from some research papers. Okay, now we are going to model wind turbine using MATLAB. For that, just open MATLAB and then click on Simulink and then create a untitled model, create model, blank model. Then click on this library browser. You will get the tool from the library browser. For that, first of all, I'm going to create a system in this only. I'm not going to use that. If I need, I will use library browser. For that, first of all, I'm going to use a subsystem. Okay, subsystem having here 2-port subsystem will be there. Click in, double click on it. So delete this. So we are going to create this one. Okay, PM, and we are going to click order. Just this one will be PM for us. Just write a name for PM. Output will be power output, will be mechanical output power PM. Okay. And then take a product because we have to create the equation. Product. I'm going to make this equation. Nothing else. I'm going to make this equation. Okay, 5000. The output power will be 5000. That's why I'm coming from this side, left to right. Okay. So product. So we have to use. Here I have to change this for 4 because 4 parameter we have to multiply. Just take 4. Apply. Okay. Before that I have to get a multiplier here, so I can take gain as a multiplier. Just connect to this. Gain would be 1 upon 2. 1 upon 2. Apply. Okay. Then it would be there. I'm going to connect to this and then just expand it. This will be your input. We are going to give 3 more inputs. Okay. So it will be first you can write this as an R. Okay. So here first one would be your A. A will be क्या? A is a pi r square. Okay, pi r square. First of all, we have to take a gain again for pi. And then we have r square. For r square, what I'm going to take, for r square, I'm going to call a function FCN. Okay. Function. So inside the function, I'm going to write u input r. I'm going to give, this is r as an input, है ना? U of 1 square. You have 1 square 2. Okay. I'm giving this as an, because r squared, pi r squared we are having. Okay, r is the input, that's why I'm giving like this. Okay, and then another input I'm going to give. That input will be VW. Okay, V. So for that I have to take another function here. VW would be function again. It would be cube. Means we are having 12 cube in the equation. Okay, means wind speed into in power 3. Wind speed to the power 3. Okay, so I have another one. It would be wind power V. And then we have to get rho. We have to multiply with rho. Rho will be just take a constant. Constant, the rho value is constant, already we know that. The value would be 1.225. 1.225. Apply. So now we have to go for CP. CP we have to create another equation. Okay, for that I'm going to call another subsystem here. Subsystem 2.1. Inside I'm going here. So we have to take, this will be CP, your value CP, this will be CP, and then here we have input, just lambda and beta. So I can write this as a lambda, the mode we need, it will be the beta. Now how can we take, just I need a function FCN. So there are two equations for that. Okay, so you can see here this equation we have to complete. So for that first I need to get a lambda I also, and then CP, this equation we have to complete. Okay, so for that I am going to write an equation for this. That will be 0.5, means 1 upon 2 will be 0.5 into bracket 116 is C1, sorry, 116 is your C2 as per the equation, into U, the first input, U into 1, this is the first one, and then we have to get minus C3. C3 will be 0.4 into U, second input, U of 2, that means that is beta. Okay, we have to, that is beta, and then into beta would be there, beta already we have taken as 0. Okay, beta will be 0, that's why this term will be not there. Then we will have C5. C5 would be 5. Okay, C5 would be 5, and then close the bracket, and then e to the power exponential of into exp exponential of minus 21 means that will be your C6 na? Minus 21 star u of I, because C6 upon lambda I is the equation. Okay, u of 1. Okay, u of 1. So just close the bracket, apply, load. It's for C. And again we have to get a mux here, because 2 input we are going to give. No? Mux would be, we have to give mux. So take a mux. This lambda and the beta we have to give as an input. That's why I'm calling mux. So connect this mux to here, and then this lambda would be there directly. You can connect the beta. Okay, so we can see this also. And I'm taking another mux here, plus both the value we have to give them to try to find where lambda I. Okay, and then I can connect beta or CP value, and then I need one more function here, FCM, because we have to make this equation. Okay, that's why I'm calling another function. Inside we are going to write 1 upon v of first input plus 0.08 into v of 2, means the equation will be lambda plus 0.08 into beta. Okay, so the second input will be your beta. That's why I'm writing 2 here. Then close the bracket, minus 0.035 divided by 1 plus u of 2 second input to the power cube. Okay, power cube, beta cube. The equation 0.035 upon 1 plus beta cube. That's why I'm writing like this. Okay, it's over. Yes, it's over. Apply and give OK. So now we can connect. So we can get CP from this place. Okay, now go to the previous one. Just connect this to here. Okay, as per this one. Actually I made the diagram already. So for reference I'm taking this. Okay, so this one, and then we have to go for another further step. Okay, so beta we have to call here. So I need to get another one. Here I'm going to do beta. You can change here as a beta. And then for lambda we have to call the saturation also. Here you can see. First of all we have to get the product one. Product. Plus we have to do the equation. Okay. Then this will be 4 to 1 W or omega or w I can write W just. Okay. Connect here. And then we have to go for divider block. So I can make this like apply, and then I have to get here this one. I have to connect with this. Then I have to go for the saturation block spool. I can say to saturation. So saturation would be infinity here, a limit infinity, and then this would be 1e minus 6. Why we are using saturation? Because lambda should not be 0. If there are any changes in the value, the lambda will get 0. That's why we have to keep our saturation. Okay, we have to keep saturation. Then I'm going to up to this, it will be the okay. Now I'm going to calculate the torque. For that, I'm taking another saturation. We have to connect one more saturation here also. Control R for rotation. Sorry guys. So I have to connect. I have to get a torque also. So torque, for that I have to take this and change it into Tm. So I have to take this block as well. Here we can get okay. Now we will go out. So we have made a turbine. Now I have to give the value for the turbine. Okay. So for that I have to call constant 1, 2, 3, 4. Okay. So first I am giving a rotor. Already we know the value for R. Be 1.91431. Apply. Okay. And then this one. This one is for 12. Already we had, I think. Yes. It's 12. Beta would be 0. P channel, we don't have any P channel. And then W will be 50.77. 50.77. Okay. Now I'm going to run this. So here I can give display. Also we have to connect a display. Inside also we can connect a display to see this. Okay. Here we have to connect. So we can go for display inside also for the value to see this. Okay. Now I'm going to run this. Before that we have to call power B. Now I'm going to run. You can see here 5 kilowatt. So value what we got by doing this. So you can do any model, any rating, power rating model you can do by using this. For an example, just I'm going to change this to 3.2, okay, and then I'm going to use this at 25. Okay. See here, what it, so it will get off any rating. Okay, you can see here 1.26 means 1 kilowatt. Okay, you can do like this, you can do anything, any model by using this model, this mathematical. Okay, thank you very much, thank you guys.